Hi! Welcome to the course Modern .NET Ecosystem and .NET Core. I'm Elias Fofanov, aka Engineer Spock from engineerspock.com, and I'll be leading you through the course. I began my career as a postgraduate student participating in Microsoft Imaging Cup contest. I've been working with .NET Platform since 2003. I've been professionally architecting and implementing software for nearly 7 years, primarily based on .NET Platform. I'm passionate about building rich and powerful applications using modern technologies. I'm a certified specialist in Windows applications and service communication applications by Microsoft. Last year, a great number of technologies came up to the world of .NET. Nowadays, we have the classic .NET framework with CLR as a runtime, Mono with its own runtime, .NET Core with Core CLR, WinRT and UWP, Xamarin, a NuGet compiler RyuJit, .NET Native, new Roslyn compiler with OpenAPI, .NET Standard, PCL, NuGet-based project management. God's sake! It's so simple to get lost in that ocean of technologies. You need to understand the overall picture to feel comfortable today. Didn't you feel like a small fish in the ocean last time? I did. I questioned myself, what the hell is going on around me? I didn't quite understand the directions in which technologies develop. I didn't know what to expect, what to learn next. In such situation you feel helpless. And what we're going to do in the course is that we're going to eliminate this nasty feeling by learning all the most important notions in the modern .NET ecosystem. One of the most profound technologies is the new .NET Core platform, so learning it is a primary goal of this course. Of course, all the way along we will discuss all the other technologies I mentioned above. In short, the course covers the following topics. Classic .NET platform, its building blocks, the history of this platform. Mono platform, its building blocks. We'll figure out if Classic .NET and Mono are compatible. We will compare Classic .NET Framework and Mono platform. .NET Core is the new cross-platform .NET framework. We will understand what's different here comparing to other .NET platforms, and what this platform means for the future of the .NET world. .NET Native is an interesting ahead-of-time compilation technology. You'll know that a form of .NET Native comes to .NET Core as well. Do you really understand what is UWP? How it is related to WinRT and what WinRT actually is? We will look at Roslyn as a compiler platform, NuGet as a system of dependencies management. Learning .NET Core, we will look at installation of .NET Core, command line interface of .NET Core, deployment in .NET Core, self-contained deployment and framework-dependent deployment, the problem of cross-compiling, portable class libraries, .NET Standard, .NET Portability Analyzer, unit testing in .NET Core, and a quick overview of upcoming changes. This course is built for all kinds of C# developers who are interested in learning the .NET ecosystem. This course is beneficial for juniors as well as for seniors who want to stay well informed about modern .NET ecosystem. I'm sure any student will find something interesting and useful in this course. The main prerequisite is to be familiar with development on the .NET platform in C#. That's all you need. Feel free to look at the course description. I am looking forward to seeing you inside the course. Enroll and start learning the modern .NET ecosystem and .NET Core. Hi, this is Engineer Spock from engineerspock.com. A great number of developers do not understand the relationships between different modern concepts. So, this module is a high-level overview of modern movements in the .NET world. In this module, we're going to talk about Classic .NET platform, its building blocks, the history of this platform. We'll talk about Mono platform, its building blocks as well. You'll figure out if Classic .NET and Mono are compatible. we will compare classic .NET Framework and Mono platforms. .NET Core is the new cross-platform .NET Framework. We will understand what's different here comparing to other .NET platforms and what this platform means for the future of the .NET world. .NET Native is an interesting ahead-of-time compilation technology. You'll know that a form of .NET Native comes to .NET Core as well. Do you really understand what is UWP? How it is related to WinRT and what WinRT actually is? Roslyn as a compiler platform, and NuGet as a system of dependencies management. Xamarin arose from the Mono platform. Xamarin has its own runtime, which is based on Mono. So, we often see that their runtimes are written as this: Xamarin/Mono. The most important part of Xamarin from the .NET perspective is Xamarin Forms. Xamarin.Forms is roughly speaking a library that allows you to build native applications for iOS, Android, and Windows using a single C# codebase. If you are familiar with WPF or UWP, then Xamarin Forms will look familiar to you as well, since it's based on XAML and we write our code in C#. Xamarin Forms allows us to write an application once and build it targeting iOS, Android, and Windows. So Xamarin Forms knows how to translate C# code into specific platforms. So visual elements of Xamarin Forms will look natively on iOS, Android, and Windows. Xamarin technology is an interesting one, so I want to dive a little bit deeper into how things work under the hood. So, at the lowest level, we have the Mono runtime. On top of Mono, we have Xamarin.Android and Xamarin.iOS. These libraries allows us not only to write shared code, but also dig into specific features of these platforms. On top, we have Xamarin Forms, which exposes unified types which we can use to build shared UI. Let's create a Xamarin application. I'll open Visual Studio. Then I'll go to File, New Project. If you installed Xamarin during the process of Visual Studio installation, then you'll see the cross-platform section within the Visual C# section. You have 7 different project templates here. Since this course is more like an overview of the modern .NET ecosystem, I'm not going to discuss all the possible options. For more information, wait for my upcoming Xamarin course. I'll pick the Xamarin Forms portable template. This template allows us to share code via so-called PCLs, or Portable Class Library. We will discuss a little bit later what it is and how it is related to .NET Standard. I'll wait for Visual Studio. It's creating projects. You can develop for iOS without Mac, so you'll see this message. It says that you can develop for iOS with a remote login. I'll cancel this window. And this window reveals what PCL is. For now, I'll just say that PCLs enable the sharing of code between different platforms such as UWP. And here you can set the minimum version your application needs to run and the maximum version on which you have tested your application. Be aware that you are declaring that your application should work on any version of Windows in the range from minimum version to target version. It is recommended to pick the most recent version as the target and perform testing on that version. I'll click OK. I feel that default values are just fine. When we create a solution in Visual Studio through the Xamarin Forms portable application template, we get the solution with 6 projects. One is for shared code via PCL. You can see that it is marked as portable. one for Android, one for iOS, and for UWP, and the other two are for Windows 8.1 and Windows Phone 8.1. As a side note, I want to say that Windows 8 and 8.1, as well as Windows Phone 8 and 8.1, are definitely dead. Yes, there are plenty of devices on these platforms, but it will not take much time to observe the extinction of devices on these platforms. 8 and 8.1 versions are the dead ends, so starting a new project on Xamarin, I would consider to avoid investing too much time into support of these platforms. Okay, so what's going on during the compiling process in Xamarin? Things go a little bit different in the case of Android and iOS. As you can see, we have separate projects for specific platforms. So, firstly, you need to understand that the resulting applications which can run on target platforms are compiled from these corresponding projects: Android from Droid project, iOS from iOS, and so on. When Android app is compiling, C# is compiling to IL, and the result will be packaged with mono runtime, including JIT compiler integrated. Unused classes in the Xamarin framework will be pruned to make the resulting package smaller in size. The application runs side by side with Android runtime and interacts with the native types via Java native interfaces. In the case of iOS, C# will be ahead of time compiled to ARM assembly language. Unused classes will also be pruned. The difference in the case of iOS comparing to Android is clear. In the case of iOS, there is no runtime code generation with jitter. Apple deprecated any kind of runtime code generation. The simplest thing happens in the case of Windows-based projects. C# is compiled to IL and will be executed by the built-in runtime. By the way, in the case of UWP, the application will be ahead of time compiled by .NET Native in release mode. This is similar to what happens in the case of iOS. We will start our dive into .NET Core from the bottom. We installed both runtime and tooling. Without tools, we can't create and manage any projects. In the end of the previous lecture, we used the .NET command. That was a command from within the .NET Core CLI, where CLI stands for Command Line Interface. It is a set of tools for building and managing .NET Core projects. CLI is also cross-platform, as you might guess. Let's run the command line again and play around with .NET entry point a little bit. First of all, remember that there is a help at your disposal, so you always can type this command. You can see here that we have 7 subcommands which belong to the .NET entry point. The last thing I want to say about help is that you can request help for the specific commands. Look at the command I'll issue. This is how you can read about specific commands. Okay, let's create a project based on .NET Core. I'll use the new command specifying the type of project I want to create. At the moment, there are 4 types of projects available. Console actually creates a console application. Web creates an ASP.NET Core project. Lib creates a library which targets the .NET Standard. We're going to learn what .NET Standard in greater details a little bit later. However, now I'll just say that .NET Standard defines the set of APIs which have to be implemented by different .NET platforms, so in the end you get a cross-platform library. The last option is for creating unit test projects. It is named XUnitTest, and you can write unit tests in XUnit testing framework. But there is also NUnit runner in alpha version, so you can actually use NUnit as well. Okay, I'll go to the specific folder on my local disk. And now I'll run the new command to create a simple console.NET Core application. Let's look at the destination folder. You can see here two files, program.cs and project.json. Let's open the program.cs file in Visual Studio. As you can see here, this is just a simple console application which prints out the so familiar Hello World string. I'll close this file. Let's look inside the .json file. Here you can see that we have a Microsoft.NET Core.app meta package of version 1.0.1 as a dependency. Before we run the application, we need to build it. Before building, we need to restore the packages our application depends on. So, let's issue the .NET restore command. Restoring is done. Now we can either build or run our application, since the run command checks if the application was previously compiled. If it wasn't compiled, it will compile it and then run. To run the application, we need to issue the run command. Great! The application is compiled and you can see the output, Hello World. Let's get back to the applications folder. The restoring process didn't download any packages into our applications folder. Instead, it generated a project.lock.json file. Let's open it with Visual Studio. You can see a full graph of dependencies. Dependencies on which our project depends on, dependencies of dependencies, and so on. This is possible because of global packages cache. We don't need to store all the packages inside project folders. Okay, I don't want to spend much time on dealing with .json project files. As you may remember, classic .NET platform works with MS-Build and .csproj files to build projects. Visual Studio developers had an idea to drop .csproj files and move to .json files. This resulted in a very strange situation when we work with both .csproj and .json project files. You'll see the idiotic situation around this during the course, but thanks to gods, Visual Studio developers decided to get back to old .csproj files. So in the near future, you'll forget about these .json files and will live without this pain. Let's get to the debug folder and look at what was generated by a compiler. Do you remember that we created a console application? The interesting thing here is that we don't see any executable files. How this is so? The thing is that actually it is absolutely possible on Windows. A DLL can have an entry point and nothing stops us from this approach. We have two types of deployment now with .NET Core. FDD, which stands for Framework Dependent Deployment, and SCD, which stands for Self-Contained Deployment. When we rely on FDD, it means that our application does not include the runtime, so when we deploy our application with FDD in mind, the target machine must have the pre-installed runtime. Otherwise, our application won't work. When we deploy our application going SCD way, we deliver the self-contained application, which contains all the necessary things including runtime, so it doesn't need anything to run on any other machine. We can copy it anywhere and just run, and everything will work fine. I'll open the command line and try to publish our console application in a release mode. To do this, I'll kick off a publish command in the CLI with -c argument, which determines the configuration. Now let's open the release folder and look at it. What we have is just our DLL with corresponding PDB and JSON files. We don't have any runtimes here deployed. So this is how FDD deployment works. SCD deployment is harder. First of all, let's edit the .json project file. I want to deploy the runtime along with the program, so our program is not going to use the .NET Core platform. That's why I'll remove the type equals platform line. Next, I'll make the runtimes section to specify which ones I want to target. I attached the link to this lecture, where you'll find all the possible runtime identifiers. Now we need to run the restore command and then build our project for each runtime. And now we need to make the last step, to publish our project. Now let's open our projects folder and look at the results. As you can see, we have 3 different folders here, each for corresponding runtime. Copy any of these folders to a target machine and it will run without any problems, and it will not require any pre-installed runtimes. For more details, follow the link I attached to this lecture.